everything you can see or touch is made of particles. The smallest building blocks of our world used to be called atoms, until we discovered that even atoms can be split into smaller pieces. Nowadays, we call the smallest of the small elementary particles. If I want to describe the behavior of this particle, I only need two pieces of information. The position of the particle tells me where it is in the space, and its velocity tells me how fast it is moving to its next event. With that information, I can use a recipe, a mathematical formula written down by Sir Isaac Newton a long, long time ago, to calculate where exactly this particle will be at any given time in the future, or where it used to be in the past. Imagine then that you would be able to freeze the passage of time just momentarily, just long enough to work out the position and the velocity of each and every particle in our world. According to Newton's recipe, that information, plus some constants, would be sufficient to work out the fate and the origin of our universe. Well, nothing lasts forever. And only 100 years ago, an improved model of our world, the machinery of our existence, was uncovered. The new quantum mechanical worldview teaches us that the particle is not always where you may think it is. As a matter of fact, the position and the velocity of a quantum particle can never be known precisely, not even in principle. It is this uncertainty that lets us off the hook of the Newtonian determinism. But it comes with a catch. The quantum worldview defies all common sense. Let me sharpen this by telling you about just one strange aspect of the quantum world, the so-called wave-particle duality, the two sides of the one and the same coin, according to which, if we want to describe a quantum particle, we need to do so by using a wave that extends throughout the world, rather than being in one particular point in time. However, if you then want to figure out where is that wave, you can take a photograph of it. And when you do so, what you will discover is that only one pixel in your camera will go click. What used to be a wave has become a particle. And if this was not strange enough, what we have learned is that this strange flip from the wave behavior to the particle behavior seems to only take place if and when we are trying to look at the wave. Now that is weird, and fair enough that nobody really understands what goes on behind the scenes, but so what? Well, as I speak, new technologies are being developed all around the world. Technologies unimaginable within the realm of Newtonian worldview. Devices whose very operation relies on the strange quantum mechanical recipe. So does that then mean that we are going to end up in a situation where the most advanced technologies and gadgets have been cooked up using a recipe that nobody really understands. So may I suggest that in order to make progress in resolving this inconvenient situation, new lines of thinking, driven by curiosity and a diversity of perspectives, is required. And with that thought in mind, please allow me to tell you about a fantastically amazing phenomenon that bears resemblance to this mysterious wave-particle duality of the quantum world. If you look very, very closely on a rainy day, you might see droplets bouncing off the thin layer of water on the ground, creating waves that spread, interfere with the neighboring waves, forming a complex network of waves and ripples and the droplets that created them. Now, these droplets only survive for a few bounces before they merge with the fluid underneath them. And so do the waves that they create fade away very quickly. However, in 2005, Yves Coudert and his team made a remarkable discovery. If you shake the layer of fluid, it is possible to make those droplets continue bouncing indefinitely, and even make them walk on the water. The droplet generates that wave guides the motion of the droplet. One cannot exist without the other. If you add many of these droplets, an incredible richness, diversity of behaviors emerges in this system that could not be predicted beforehand. So is this then a realization of this mysterious wave-particle duality I described to you earlier? Yeah, not so much. For these droplets and their waves can actually be fully, at least in principle, described using the Newton's recipe without having to resort to these new and mysterious quantum rules. Nevertheless, I do claim that if you actually get to see these droplets and their mesmerizing behaviors in real life, it is just as thought-provoking as learning about the quantum mechanical wave-particle duality itself. And if this inspires even just one of you to think outside of the box, look at the quantum mechanical worldview through a different lens, it may be sufficient to bring a resolution to this 100-year-old puzzle and pave way for future technologies that will benefit us all. Thank you.